Welcome back. In our last session, we explored how memories are formed, why deep processing beats simple repetition, and how your brain organizes information into vast associative networks. Today, we're going deeper. We're going to look at what your memory actually stores, why you forget someone's name the moment you leave the bank, and whether men and women remember things differently. Let's get started. Part 1. You keep the gist, you lose the details. Semantic encoding. Here's a truth that surprises a lot of people. Your long-term memory is terrible at recording exact details. It's not designed to be a video camera. It's designed to extract meaning. Psychologists call this semantic encoding. When you experience something, your brain asks, "What does this mean? What's the essence?" Then stores the essence and quietly discards the surface details, the exact words, the precise numbers, the order of sentences. Example, you read a detailed news article about a new climate policy. An hour later, a friend asks, "What did it say?" What you remember, the government is introducing a big carbon tax to fight climate change, and it'll affect energy prices. What you forget, the exact headline. The specific percentage of the tax. The minister's quote word for word. The order of the arguments. Why? 'Cause your brain is ruthlessly efficient. It extracts the so what and throws away the linguistic packaging. This is usually helpful. It stops you from drowning in trivia. But it has a dark side. This tendency is why false memories are so common. 'Cause we store meaning, not exact copies, we often remember things that were implied but never actually said or shown. In one classic study, participants read lists of related words, winter words like cold, snow, ice, shiver. Later, most people confidently remembered that the word snow was on the list. It wasn't, but it fit the meaning of the list, so their brains supplied it. This also explains why you probably can't draw a correct penny or euro coin from memory, even though you've seen one thousands of times. You know it's round, metallic, has some writing and a face. That's the gist. The precise arrangement. Your brain never bothered to encode it. It wasn't meaningful enough. This insight has actually influenced real-world design. Currency designers now make coins and banknotes more distinctive, different sizes, different colors, different textures, because they know we don't memorize exact details. We memorize distinctive features. Part 2. Do men and women remember differently? Now, let's address a sensitive but scientifically studied question. Are there differences in how men and women encode and retrieve memories? Research suggests some interesting patterns. On average, studies have found that women may have richer autobiographical memories, more detailed, more sensory, more emotional, and better recognition memory for things like faces. This may be linked to more detailed visual scanning during encoding. But, and this is crucial, these differences are not fixed or universal. They can be reduced or eliminated with repeated exposure and intentional effort. Example, a couple is reminiscing about their beach vacation from 2 years ago. They both loved it. But listen to what they recall. He might say, "We went to Maui in July. Weather was great. We went snorkeling one day and hiked the volcano another. The flight was long." She might say, "Yes, I remember the feeling of the warm sand that first morning. You had sand stuck to your sunscreen. The snorkeling guide's name was Kai. He showed us that bright yellow trumpet fish. I wore my blue sundress to dinner and you spilled pineapple juice on it. The air smelled like plumeria." Now, is he remembering worse? No. He's remembering the broad strokes, the factual outline. She's weaving in sensory and emotional threads, touch, smell, names, colors, humor. This aligns with the theory that women, on average, may engage in more elaborative encoding for personal events. They connect the memory to more contextual details, creating a richer, more easily retrieved trace. Again, average tendencies, not rules. But it's a fascinating window into how different brains can encode the same event in different ways. Part 3. The Power of Elaboration, Craik and Tulving's Breakthrough. Speaking of elaborative encoding, let's look at a landmark experiment that proved its power. Craik and Tulving, 1975. They gave participants words to remember. But they didn't ask them to memorize. Instead, they asked simple yes-no questions about each word. For some words, the question was simple. Is this word in capital letters? For others, it was more meaningful. Does this word fit the sentence? He met something in the street? The result? Words that were processed in a rich, meaningful context, even just a simple sentence, were remembered far better than words processed superficially. And this happened without anyone trying to memorize them. Conclusion. A rich, meaningful context during encoding, deep, elaborative processing is more effective for creating lasting memories than simple repetition. You don't have to try to remember. You just have to think deeply about what you're learning. Example, you're studying for a history class. The Stamp Act of 1765 was a tax imposed by the British Parliament on the American colonies. Shallow processing cramming. You stare at the flashcard, Stamp Act 1765 tax on colonies. You chant it 20 times. Row acoustic repetition. Isolated fact. Result, you pass the quiz. A month later, it's a vague, floating factoid. You can't explain why it mattered. Elaborative rehearsal, creating a narrative. You don't just read the fact. You explore context and meaning. You learn. The colonists were furious because it was taxation without representation. They saw it as the British treating them as a cash cow. This led to protests, the Sons of Liberty boycotts that hurt British merchants. It wasn't about the money, it was about the principle. This was a major step toward revolution. Result, you remember the date and name because they're now part of a compelling story. You can explain significance, predict consequences, connect it to other events. This is deep semantic encoding. This is memory that lasts. Part 4. Encoding specificity, why context is everything. Now, here's a principle that will explain half the awkward social encounters you've ever had. The encoding specificity principle. It's simple but profound. The way you encode information, the context, the meaning, the mental pathways you build at the moment of learning determines how easily you can retrieve it later. In other words, your memory is not a search engine that can find anything from any starting point. It's more like a set of keys. Each key only fits the lock it was cut for. Example, you see your strict, formal bank manager at the grocery store on a Saturday morning. Jeans, t-shirt, laughing with a child. You stare. You know them. But you cannot place them. What's happening? You have only ever encoded this person in one specific context, behind a desk in professional attire in the bank. That's the only key you have. Seeing them in a completely different context, casual clothes, family role, supermarket, fails to trigger the neural pathway associated with their identity. The moment they speak, or you mentally picture them back at the bank desk, the original encoding context is re-established. Suddenly, oh, Mr. Jones, I didn't recognize you without your suit. This is encoding specificity. Your memory for the person is bound to the context in which you learned them. Here's another example, more linguistic. Imagine you learn the word beat, B-E-E-T, in a music class. Your teacher says, you need to feel the beat, the rhythm of the music. You encode it as beat. Later, at a supermarket, someone asks, Can you name a root vegetable? You think carrot, potato, parsnip. But beet doesn't come to mind. Why? 'Cause the pathway you built for that word was attached to music and rhythm, not to vegetables. You encoded it in one context. Retrieval is failing because the context has changed. This is why studying in the same room where you'll take the test can actually improve performance. You're not being superstitious. You're reactivating the physical context that was woven into your memory during encoding. Conclusion: memory is constructed, not recorded. So, let's bring this all together. 1. Your memory is primarily semantic. It stores meaning, gist, essence, not exact copies. This makes you efficient, but it also makes you vulnerable to false memories and forgetting details. 2. Elaborative encoding, weaving new information into rich, meaningful networks, is far more powerful than simple repetition. If you want to remember something, don't just repeat it. Connect it. 3. Context matters enormously. The mental pathways you build during encoding are the same pathways you need to travel during retrieval. Change the context, and you might lose the memory entirely, even if it's still in there. For memory is not a passive recording. It's an active, constructive process. Every time you remember, you are rebuilding the past from fragments of meaning, association, and context. That's why it's fallible. That's why it's personal. And that's why it's so extraordinarily human. Thank you for joining me.